This lesson is about how to use rotational symmetry and how to map a figure onto itself. So let's go ahead and get started. So in this first example, it says determine the angle of rotation that will map the figure onto itself. On these types of problems, you have to make sure that the polygons are regular. What regular means is that all of the sides are equal and all of the angles are equal. So in this problem, that is in fact a regular polygon. So the way we map a figure onto itself whenever we have a polygon is we're not going to use any kind of transformation rule. All we're going to do is put a dot in the center, and then you're just going to kind of break it up like a slice of pizza. So you're going to go from the center to the angle, center to the angle. And you just continue that trend all the way around your shape. Okay, so it's going to look something like this. What you're going to do from here is a full complete rotation is 360 degrees. So we're always going to start with 360. What we want to do is figure out how many degrees one turn is, because that would take this vertex onto this one. So from here, all you have to do is count the number of sections you've created. So 1, 2, 3, 4, 5, 6, 7. So you're going to take 360 and divide it by 7. So 360 divided by 7 is 51.4. And that is the angle of rotation that when rotated will map that figure onto itself. So basically what we're doing is we're taking the center, and if I trace my shape out, we're trying to figure out how many degrees it takes to turn this shape and have it end up back on itself. And that rotation ends up being 51.4 degrees. So let's try another one. We're going to do the same thing. You put your point in the center, and then you just extend your lines out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're still going to take 360, but this time we're going to divide it by 10 because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you keep track of how many lines you're drawing as you're counting, then you'll know exactly the number to divide by. So 360 divided by 10 is 36. So a 36-degree rotation will take this figure back onto itself. Let's try one more, and this here is a square. So we're going to go ahead and put the dot in the center. 1, 2, 3, 4. 360 divided by 4 is 90. So a 90-degree rotation would bring this corner onto the other corner. Our next type of problem involves the actual shape, but you're mapping a number on top of another number. On this top piece, we're just rotating the shape. On the bottom section, we actually are having to map 1 onto 2, meaning how do we get 1 onto 2? Okay. So let's go ahead and start. The map is pretty much the same, but with one additional step. So the first thing we're going to do is the same as we did before. We're going to put the dot in the center. We're also going to go ahead and break up our shape. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to take 360 and divide that by 10, which is 36 degrees. Now, in order to get 1 onto itself, we want to know how many degrees that takes. So in order to figure out how many degrees to turn your shape, you just count the number of sections. 1, 2. I need to turn it 2 sections, and the way we're going to do this is we're going to take our 36. We want to multiply that by 2, and we get an answer of 72 degrees. So we have to turn the shape 72 degrees, and let's go ahead and specify that that was counterclockwise. As far as the distance around using clockwise versus counterclockwise, use the shortest method. Usually that's the method you want unless it's specifically saying you have to go clockwise or you have to go counterclockwise. I always just do the shortest distance, and then you can always check your answer and see if it appears. So on this, again, we break it up just like before, but now you just count how many sections you need, and we needed 2. Let's try the next one. Put the dot in the center, and you draw your segments. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This one is 12. So we're going to do 360, divide that by 12, and we get 30. So each turn is a 30-degree rotation. We want to get 1 onto 2, so we just count 1, 2, 3 turns. So 30 times 3 is 90. So in this direction, we went clockwise. So a 90-degree clockwise rotation, we'll get 1 onto 2. Let's try one more. Same pattern, same idea. We're going to go ahead and put the point in the center. Draw our lines out. So 1, 2, 3, 4, 5, 6, 7. So we're going to go ahead and do 360 divided by 7. And this one gives you a decimal. It's 51.4-ish, give or take. So we're going to go ahead and just leave it as 51.4. We want to map 1 onto 2. Make sure you're going the right direction. So 1 to 2, not 2 to 1. We're going 2 units. So we're going to do 51.4 times 2. So 51.4 times 2 gives us a 102.8-degree rotation, and this direction is clockwise. So notice the difference between the top and the bottom section. On the first section, we just wanted to know how many total degrees it takes to map the shape onto itself. On this problem down here, when you're mapping 1 onto 2, you actually have to count the number of sections you're going. So this just finds 1 section. This lets you know how many sections you need to go to get 1 onto 2. So they're pretty much the same, only on this bottom part you actually have to use the measurement that you found after counting. And that's how you do rotational symmetry.